Okay, so today we're going to look at graphing lines in slope-intercept form. So you're going to be given some equations, and your goal is going to be to graph that line. Okay, so learning target, I can use slope-intercept form to graph a line. Okay, so what is slope-intercept form? Okay, this is slope-intercept form. It's also it's what a linear equation looks like. Okay, so linear equation equals y equals mx plus b. It's kind of a weird way of saying it, right? Linear equation equals y equals mx plus b. This is a linear equation, and this is also slope-intercept form. We call it slope-intercept form because you're given the slope and you're given the y-intercept. Okay, so slope-intercept. Okay, we'll look at point-slope form at some point. And with point-slope form, you're given a point and a slope, not the y-intercept, but this one you're given a point and you're given this intercept, so slope-intercept. Okay, as a reminder, m, okay, the m is your slope, okay, and it's how much y increases when x increases by 1, okay? So that's what your slope tells you, okay? The slope tells you how much y increases when x increases by 1. So slope is 2 and x is 1. Well, 2 times 1 is 2. But if x goes up to 2, 2 times 2 is 4. X goes up to 3, 2 times 2 is 6. X goes up to 4, 2 times 4 is 8, and so on, right? So your slope tells you how much this number is going to go up each time x increases by 1. Okay, the y-intercept is b. Okay, so a little arrow there. So this is my y-intercept. And the y-intercept tells me where the graph crosses the y-axis. So where the graph crosses the y-axis. Okay, so m is slope, b is your y-intercept. That's why we call it slope-intercept form, and this is kind of the form we always see when we talk about linear equations. Okay, we're not talking about quadratics yet or anything like that. All right, so now we're going to get into some examples of graphing these lines given slope-intercept form. Okay, so example number 1, I already drew out my graph. I went 5 this way, I went 5 that way, I went 5 that way, and went 5 this way. If you need to pause the video and copy that graph, feel free. I'd suggest using a ruler or straight edge. Okay, and we're going to look to graph this line. So y equals 2x minus 3. Okay, that's what we want to graph here. All right, so we're graphing this equation, and given this equation, it's already in slope-intercept form. Okay, so we have the slope and we have the intercept. So here's my m, my slope, and here is my b. Okay, now when I graph these, I'm always going to start with the y-intercept because it's an easy point to graph right away because I know it's on the y-axis. So if my y-intercept is at -3, I just go to the origin, 0, 0, and I go down 3. Okay, 1, 2, 3. Okay, there's my y-intercept. That's where I cross the y-axis. I can graph that point right away. Okay, so I'm starting with y-intercept. And next, you're going to use the slope to graph other points. Okay, so remember that slope is equal to rise over run. Okay, so slope is equal to rise over run. And remember, rise, we count how far we rise, how far we run, and that gives us the rise over run or the slope. We know our slope here is 2. So I know that the rise over run is equal to 2. Okay. But you might be looking to say, hey, rise over run, this is a fraction, right? I have something over something to give me 2. Well, 2 over 1 gives me 2, right? So if I just have a number here, if I have 3, 4, 5, 6, 7, 8, whatever I want to use for rise over run, it's just going to be 8 over 1, 9 over 1, 10 over 1. If it's -5, -5 over 1, and so on, okay? Because 2 over 1 is just 2. So a slope of 2, that means rise over run is equal to 2 over 1. So if I'm using rise over run, you need to make this a fraction, 2 over 1. And now I know to graph other points, I can start at my y-intercept and I can rise up 2 and go over 1 to make a point. So I'm going to go here. I'm going to rise up 2, make a tiny little dash, and I go over 1, and I'm going to have a point right there. Okay. Now I can go rise up 2 and run 1 again. So I can rise up 1 and go over, or 2, I mean, and run 1. There's a point. I can rise up 2 more and go over. There's another point. Okay. And if I even want to go backwards, I can, right? So if I want to go backwards from this point, well, I know to get from whatever's down here to here, I have to rise 2 and over 1. So if I reverse these, okay, if I want to go backwards and I want to graph to the left, okay, I'm going to have -2 over -1. Okay, this keeps my slope of 2, but instead of rising 2 and going right 1, right, I got to rise 2 and I go right 1. If I want to go left, I need to go left 1, and I'm going to have to go down 2. So if I want to go backwards, I'm going to go 1, 2, 1. And it should line up in a nice line, so just like that, okay? Once I make my points, I can take a straight edge, ruler, draw a line through everything, and arrow, arrow, and we're good. There's our equation. There's our graph, okay? So pretty simple. I'm going to write out some steps now to follow for graphing in slope-intercept form. So steps for using slope-intercept form to graph. It'll get a little bit harder than this example here. So step number 1 is going to be to solve equation for y. Okay. So you won't always start with slope-intercept form, but we're going to have to get to slope-intercept form. So to get to slope-intercept form, we're going to have to solve equations for y. Okay. So we should have something that looks like y equals mx plus b. If we don't have y equals mx plus b to start, we need to get to this point. So solve the equation for y is step 1. Step number 2 is once we've solved the equation for y, we're going to plot the y-intercept. Remember that the y-intercept is b, right? That's what the y-intercept is. It's the b. So I plot the y-intercept, which is b. Step number 3 is going to be to use the slope as a fraction to graph rise over run. Okay, so you want to use the slope as a fraction or use rise over run to plot the slope. So I'm going to say use the slope. I'm going to say rise over run as a fraction to graph line. I'll have to move my notes over. To graph other points, we'll say, to graph the line, whatever, however you want to say it. And step number 4 is obvious one, I hope. Okay, once I make my points, I'm coming down the home stretch, all I've got to do is connect with a ruler. Okay, connect the points on a line. Okay, so plot points, connect in straight line, and draw arrows. Okay, so that's my step number 4. All right, plot the points, connect in straight line, and draw arrows. And actually, plot points you kind of do up here. So we actually should get rid of that. We're going to remove that one just so it doesn't get confusing. There we go. So whenever connect in straight line and draw your arrows. Okay, so those are the 4 steps. Solve the equation for y, y equals mx plus b. plot the y-intercept, use the slope as a fraction to graph other points, and connect in a straight line. So that's basically what we did up here. We started with the y-intercept. We found the slope as a fraction, 2/1. We made our other points, and then we drew a straight line, and we threw the arrows because this line keeps going. Okay, it keeps going that way, and it keeps going that way. It doesn't just stop. All right. So let's do. I got a couple more examples here, and we'll get out of here. So example number 2, and I've already made my graph again. So if you need to pause the video, I go 5 this way, I go 5 that way, I go 5 this way, and I go 5 down. Okay, that's how I make my graphs. Use a ruler if you got one. And the equations we want to graph here is going to be 3x plus 2y equals, we'll say 4. So 3x plus 2y equals 4. All right. So this is not slope-intercept form. Okay, slope-intercept form, it's already solved for y. I have the slope, I have the y-intercept. I don't have that here. So the first thing I need to do is I need to get y alone. I need to solve the equation for y. Okay, so to get y alone, first I need to get rid of the 3x, right? I don't divide by 2 yet, right? I'm going to worry about any addition or subtraction junk first. So I'm going to get rid of 3x. So I'm going to do this. I'm going to do that. And that's going to leave me with 2y equals 4 minus 3x. Okay. Now I have 2 times y equals 4 minus 3x. So to get y alone, I need to get rid of that 2. So I'm going to get rid of the 2 by dividing. Divide. And I'm going to move over here. Give myself a little more room. So I'm left with y. And that's going to be equal to, so 4/2 gives me 2. And negative 3x over 2, I can't simplify that fraction. So this is going to give me 2 minus 3/2x. Okay. Now, we like to have things in slope-intercept form. So we want to have y equals mx plus b. So my m is right here, right? It's minus 3/2 x, 3/2x. So I'm going to have y equals negative 3/2x. And then my b is right here, just positive. I'm just reversing the order, basically. Okay, so I'm just reordering this. So my x stuff goes first. So here's my m, there's my b. I just had to reverse the order of that. Okay, so now I'm in slope-intercept form. I have my slope, and I have my intercept. Okay, now to graph this, I start with the y-intercept. So here's my b. Okay, so I'm starting at the origin. I just got to go up 2, 1, 2. And my slope, the slope equals rise over run equals right here. So there is my m. So negative 3/2. So if I have a negative rise, that means I'm actually going down. I'm actually falling. Okay, so if I have a negative rise, I'm going down. So this gives my up and down. This is my left or right. So since I'm going down 3 and right 2, I'm going to have to go back to, I'm going to the y-intercept. I'm going down 1, 2, 3, and I'm going over 2, 1, 2. So I have a point there. If I want to make another point, I go down 1, 2, 3, and I go over 2, 1, 2, right there. And if I want to go back the other way, well, I know to come down from here, I'd have to go whatever, this point somewhere up here. I don't know where it is, but I know I got to go down 3 and over 2. So if I want to reverse that, I would have to go left 2, up 3. So if I want to go backwards, instead of going down 3, over 2, right 2, I'm going to go left 2 and up 3. So I'm going to go 1, 2, 1, 2, 3. I'm going to point back there. Now I got 4 nice points, and they're all in a line. So my graph should be pretty good. I made my points right, I think. And I can take a straight edge, a ruler, whatever you got, line my points up, and draw a line through all of them. Okay, my points might be a hair off a little bit because my coordinates, I don't have a perfect graph paper, but all of these should be on the line. Okay, don't forget your arrows, and that's it. That's example number 2. Now, example number 3 might seem a little bit trickier, but I think it's actually the easiest. So example number 3, I already made my graph. Again, if you need to pause the video, I go 5 up, 5 right, 5 left, 5 down. And I'm going to say that you want to graph a line that passes through -2, 0 with a slope of 3/5. Okay, so it passes through this line with a slope of 3/5. So I'm going to say this is a point plus slope example. Okay, so given a point, given a slope, you want to graph this line. The other ones we were just given the equations, right? This time we're not given the equation, we're given a point, and we're given a slope, all right? So what we're going to do here, instead of graphing the y-intercept, we're just going to graph this point, okay? Because we're given this point. We know the line hits this point here. So here's my x, there's my y. So I go to my origin, and if I go back to -2, I need to go left 2, and my y doesn't move, it's just 0. So I got a point right there. So that's the point I'm working with instead of the y-intercept. Okay, before we started with the y-intercept, and then we graphed other points. All we're doing now is we're starting with the point that we're given, -2, 0, and we're going to do the same idea and use this slope to graph my other points. So my slope here, so slope, again, equals rise over run, is equal to 3/5. So I'm rising 3 and going over 5. That's what my slope looks like. So I go to this point, I'm going to rise up 3. So there's 3, and I'm going to run 5. So I'm going to run 1, 2, is that 1, 2, 3, 4, 5. So I rose 3, ran 5. If I want to go backwards, I have to add a couple dashes over here, I think. If I go backwards, I'm going to go down 3 and left 5. So I'm going to go 1, 2, 3. And I'm going to go over 5. So I'm going to go 1, 2, 3, 4, 5. And I'm going to have a point right there. So now I made 3 points on my graph. Connect them in a straight line. Draw my arrows. And we're done. Okay. So again, you want to have a ruler to connect your lines nicely. If you can sketch, you might be able to get away with some sketching, but if we quiz or test over graphs eventually, your graphs have to be accurate. Okay, they need to be pretty precise. If I see a graph and it should go through a point and your graph doesn't go through that point, that graph would be incorrect. Okay, so sketch your graphs the best you can. I understand not everybody has graph paper, but try to use straight lines to make your graphs as good as they can be. Okay? If you have questions, bring them to our Google Meets. Have a great rest of your day.